Welcome to second session of this reinforced concrete structures. I would like to continue from here how the concrete and reinforced steel is behaving when it is together. So ductile nature of failure you can experience when you add the steel into the concrete. Of course, the design properties of concrete are like characteristic compressive strength, modulus of elasticity, creep and shrinkage, impermeability, durability, etc. Then how to represent the type of concrete on the basis of its quality? It's a question. If you talk about the grade of concrete, this is measured by standard test on concrete cube, that is 150 mm by 150 mm cube, which is there in the laboratory standard cube. So from this you can ensure that how the concrete is getting measured. Say if you take the example of M20, so here M refers to mix and 20 refers characteristic compressive strength for the successful completion of 20 days expressed in MPa, megapascal. So that also you can say in Newton per mm square. So the grade of concrete we are talking about cube point of view, but you can see the table is available in IS 456 2000. So types of concrete: high strength concrete above M60, standard concrete from 25 to M55, and normal concrete strength concrete M10 to M20. So this is of course given in the code book. So based on this we will prefer the which grade of concrete we required. For suppose there are very light works, we may recommend the normal strength of concrete. But what is the characteristic strength? That is the main point here. If you talk about the characteristic strength, FCK, which I already explained earlier, but you can see in the visually the photographs are there. We have to collect the cubes from the site, which concrete we are using for the particular construction, and we have to test it in the laboratory. Then definition point of view, it is defined as the strength of metal below which not more than 5% results are expected to fall. So that is from normal distribution, like normal curve if you see. So one side compressed strength is there for the 28 days successful strength and specimen, that is a 5% area you can see, and from that center point to where it is falling, that point, that is 1.65 sigma. So sigma indicates that your standard deviation, and this is all about target mean strength, which is being given in the code book, that is M equals to FCK plus 1.65 s sigma. Subjected to considerable variation in strength, the variation in concrete is expressed in terms of standard deviation. Of course, values of standard deviation is also being given in code book IS 456 2000 based on grades of concrete. For M10 and M15 we can take it as a 3.5, and for M20 and M25 we can take 4, and more than 30 it can be considered as a 5. Then if you look at the modulus of elasticity of concrete EC, concrete basically brittle material, and if you see the strain and stress diagram of concrete, it's a non-elastic, non-linear also, and it's of course if you look at the idealization of the concrete curve, so it should be straight actually, but in only initial portion of curve is linear, frankly speaking. So what is meant by EC? The slope of the stress strain curve is nothing but a Young's modulus of that particular graph, concrete stress strain curve. So stress by strain is nothing but a Young's modulus. But here strains are two types. One is short term elastic strain, long term elastic strain. Of course, short term is the instantaneous load, so it will happen due to intense load, but whereas long term due to creep and shrinkage it will happen. Then EC equals to short term modulus of elasticity, ECE equals to effective modulus of elasticity, Possible type of EC, short-term strain, initial tangent modulus ITM. So that is tangent because if you look at the secant modulus, so how it is touching to the tangent. So that is secant modulus and tangent modulus where it is touching. So that meeting point is very important to find out your EC, that modulus of elasticity for that concrete. Why? Because when we are not able to get the straight linear line, when we are getting the curved line, for locating that one, it should be we need some idealization. So this is as per code, that empirical expression I already explained you. But this is the typical understanding from the visualization based on ITM, okay, initial tangent modulus method actually it is. So in that way we can identify the location of the exact point of the modulus of elasticity. Then now let us talk about tensile strength of the concrete. That empirical expression is also being given, but it's tentatively 7 to 15% of compressed strength only will be there as a tensile strength of concrete. Tensile strength tests, direct tension test, splitting test, flagellal tension test. So direct tension test, you can see in the photograph how it could be tested for the concrete. Secondary stresses induced due to gripping, so it will fail suddenly because of brittle nature. And there is another test, direct split tensile stress test. So from there also you can see the tensile strength of concrete. So that is another way of finding the tensile strength. Then another one is flexural tension test. So now you can apply the load. The size of the member is 100 mm by 100 mm by 500 mm. So it's a one small beam or prism. You can apply the 3-point load method, at center point load method, load pin, and there are 2 supporting points are there. Then you can see the effect, how it is deflecting and how the crack is getting over there. Then modulus of rupture, actually we used to call that tensile strength of concrete is nothing but the theoretical maximum tensile stress reached in extreme fiber. So what it indicates, from M by A equal to F by Y equal to E by R, that bending expression is there. From there FCR can be calculated by applying the M by Z. What is Z? Z is section modulus, that can be calculated from modulus of moment of inertia divided by Y. Y is the distance from center of the cross section, so that is d by 2. Then what is empirical formula suggested by code, actually, that FCR equals to 0.7 root FCK. Here the root FCK is the compressive strength of concrete. It is an empirical one, not exact one. So empirical sometimes of course you can use for the calculations, direct calculations. Of course relation between tensile and compressive stress is that FCR, and there is a FCK is also there. So that is all about the discussions. Then whatever we have discussed about the modulus of elasticity. Now let us talk about creep. Of course the time dependent component of total strain, actually it can give the in vertical axis total strain, in horizontal axis in time. It will happens due to instantaneous strain, actually. So when you talk about the first one, the next one which is happening, that is due to creep strain. So both depends on stress levels, actually. Both depends on stress levels. So this creep strain is very dangerous than regular creep strain. So of course there is a creep strain which is being given in the code book, that is creep strain at a time t, incidence strain divided by incidence strain. So there is ultimate creep strain, you can see in the graph. Of course as per code, creep coefficient for design from IS 456 2000 clause number 6.2.5.1 for 7 days, 20 days and for 1 year, the theta values is being given, that is 2.2, 1.6 and 1.1. So you can see here there is a last point, unloading the zone. So when unloading is happening, instance recovery will be there. So creep recovery also will be there. That means when you are trying to apply the load, and it will try to regain the original position, and at final you can see residual creep strain. The effective modulus of elasticity EC or long-term modulus is the main thing when you consider the creep. So that is a formula is being given in the code book, how to find out the creep strain. That means long term deflection, if you want to find out. Then shrinkage, this is also long term deflection. Then concrete shrinks hardened state due to loss of moisture by evaporation. If you look at the dry shrinkage, reduction in volume of concrete, it happens basically. So shrinkage is similar to creep actually. It is induced time dependent strain. Unlike creep, independent of stress level, even a shrinkage restraint developed tensile stress lead to cracking. So that is all about your shrinkage discussion, how shrinkage will occur. Then there is another shrinkage, differential shrinkage. It will happen due to moisture or thermal gradient, or due to unsymmetrically placed reinforced steel in beam. So induced internal stresses, curvature, even deflection, these all comes under the differential shrinkage. So what will be the effect of unsymmetrical distribution of reinforced steel on structure? So that is a question mark. So when you talk about the creep or shrinkage, so we should be in a position to answer for the direct problem of asking question. Then shrinkage strain for design expressed as linear strain, that is mm by mm. In IS 45000 clause number 6.2.4.1 it is being given. Then the next very important properties of the concrete is durability. What is durability of concrete? Concrete is to serve the purpose for which it is designed during its intended lifetime. Some factors which affect the durability of concrete. There are like internal factors, of course external factors. What could be the internal factors? Properties of ingredient used to make concrete, alkali reactive concrete aggregate, salty water, then environmental effects. This is all about external factors actually, environmental effects, maybe sulfate attack due to rain, then wind effect, this all comes under the environmental effects. Effective way to increase the durability is, the best solution is provide adequate clear cover to embedded steel. So that is very good thing. You can see from the photograph here. You have to ensure the clear cover on all sides, not only at the bottom, on all sides. If you ensure, then it will maintain the very good durability. Otherwise, if it is exposed to air, direct air entrance will happen and there is a chance of corrosion. Using coated steel is also very good thing to increase the durability. Using appropriate materials. Then there are some environmental exposure conditions you can see based on mild, moderate, severe, very severe. Then description point of view, protected against weather or aggressive conditions except if located in coastal areas. Then you can see here sheltered from severe rain or freezing with wet or exposed to condensation. This is a condition in moderate. This we can use for M25 30. Like similarly, if you see the mild, it will start from minimum grade is M20. The minimum cover is 20. Whereas minimum cement content is minimum cement content is 300 and maximum free water cement ratio content is 0.55. Whereas in the moderate condition, M25 is the minimum grade and the minimum cover is 30, minimum cement content is 300, similar to mild condition, and 0.5 is the maximum water cement ratio, and M30 is comes under the severe, and very severe M35 will comes under. For that, minimum covers are being given, but minimum cement content is also being increased for the very severe condition, that is 340. Then maximum free water cement content is 0.45. Then extreme condition is there, that if you see, that is M40, 75 is the minimum cover you have to maintain, and the minimum cement content is 360, whereas the maximum free water cement ratio content is 0.4. So with that note, I would like to stop the session 2 and I'll continue with the session 3. Thank you one and all.